Hello everyone, this is Janardhan from NDAC team. So here in this part of the training, we will go through the NDAC system on how to access the metrics data that are available in NDAC and make it available for a customer or partner to view the metrics data of radio or the MCN core and visualize them in their external data system. So the first part is on network management APIs. I think we'll touch upon how we do this. How do we access the data from NDAC? Okay, in this architecture picture, we can see that uh, we have, once we look into the right part of the picture, we see that we have this customer network where we have different base stations placed, and we have a edge closed, which will be residing on the customer network. The base station would talk to different UEs and communicate with them. So the data would flow for the UEs connecting to the edge, and it will set up different calls for the UEs. And coming to the how the management plane is going to work, the BTS would collect different metrics for, say, like the faults that are seen in the eNodeBs Bs or the performance measurements of the eNodeBs Bs would be collected by the base stations, and that would then push to the edge cloud. The edge cloud would then push all those metrics data to the NDAC cloud. So at NDAC, we have a centralized database which would collect all the metrics data coming from the eNodeBs or from the edge cloud, and would be stored here. So once we have all the data in NDAC cloud, we have exposed the APIs for the customers or the partners to get the access to those information, and through the API calls. So by taking those data from the NDAC system, one can a, visualize different KPI data. So in short, we can call this APIs and get the data visualized in the external system. So just to show like how would the metrics look like, I'll just quickly show this slide, which would show what will be the output of the KPI data. So this is the kind of dashboard one can visualize um, from the NDAC system. So, but to set up how one can view this dashboard, so I'll go and explain here. So one has to have an API calls done periodically and set up the interface for this system. So um, we have a module called OSS Mediator, which is available in Nokia GitHub as well, which is developed by Nokia team, which would be needed as a kind of software, which would be installed on any Linux machine in the customer premises. So that software would then use these REST API calls provided by NDAC system to call it periodically, and the data that is collected periodically would be sent to the plugin. So the mediator plugin which is there can be connected to any of the next external network management system. And if a customer or partner have their own network management system, they can get this mediated data into their system and visualize the data. So from this architecture, taking this as the reference architecture, in NDAC, we have developed a solution here using an Elastic plugin, which would put the data into the Elasticsearch database. So we have this OSS mediator module split into two modules, which is the first part is called the collector, and the second part is the plugin module. The collector would call the REST APIs. So the APIs are available to get the metrics data for the faults that are generated in the NDAC system, or the faults that are generated by the radio modules or on the core edge. All the faults can be retrieved through the fault management metrics API. And we have a performance management metric API available, which is currently supporting the supporting to retrieve the metrics performance metrics data from the eNodeBs. So these APIs using these APIs, the data that is collected by the collector would be then pushed to the Elasticsearch database using this Elastic plugin. So here, once the collector collects the data, the Elastic plugin would then periodically take the data and make different calls to push it to Elastic DB. So the Elastic plugin is used here to push it to Elastic. So if you have a different kind of database installed in a customer premises, a different plugin needs to be developed, and that plugin can push the data to the right database that it is mediating with. So in this whole reference implementation that Nokia is providing, we are using this Grafana software that is available to plot the KPIs. So if I just show that dashboard, this is the kind of dashboard that is available through the Grafana. So the KPIs, like all these KPIs that are visualized here are plotted using the KPI formulas that are provided by NDAX system. So coming back here, so the eNodeBs are going to generate these faults and the performance management data periodically. So the faults are generated whenever a fault is seen, and that is pushed to the NDAX system as and when it is seen. And the performance management data is pushed every 15 minutes from the radios. So those data gets collected here. From the collector perspective, from this overall OSS mediator perspective, what we do is we collect the fault data every minute by polling the FM API, and the performance management data is pulled every 15 minutes, which is in sync with the data that is being generated by the our eNodeBs or the access points. So once this data has been pulled here, this data is stored, and the Grafana also on the Grafana we can visualize those data accordingly. So coming to the dashboards and KPIs. So I've shown the actual dashboard, but here I'll go and explain what it means. So we have different tabs here, which would say the type of data source that the Grafana is pointing to get the data, and the type of network that it is connected to, for which the graphs have been plotted. And you have an option to select different all the access points, or only one of the access point to visualize it, or you can even drill down the viewing of the metrics at cell level or at the complete eNodeB level. So this is something that is available here. And you have another option to select the time range, wherein you can select the duration for which the metrics has to be displayed. So here you can see that the metrics have been selected for a duration of last 24 hours. And there's some delay added here. So once you can see once these selections have been done, you can see the different KPIs being displayed here. At the top, at the first plane that has been shown here, the data is selected at eNodeB level, and in the second plane you can see the data is selected at cell level. So when the object is selected at eNodeB level, if there are multiple carriers that are available on that particular eNodeB, so all those data received from multiple cells or multiple carriers are aggregated and as shown as that single performance counter. But if you have two carriers, then you can see there are two cells. Each of the cell data is displayed separately. So that's the way the metrics can be visualized here. So going to the next slide. Here we talk about the list of KPIs that are currently available in the dashboard. So these are a kind of subset that are made available, or we can consider these are some of the most important KPIs that NDAC sees as that one needs to visualize. Okay. So from the overall perspective, all the counters that are generated by the NDAC system is available as counters, and if I go back to the thing, so all the counters that are generated by the eNodeB is available through the REST APIs, and it is being collected by the collector, and it is stored in the Elasticsearch database. In the Grafana, you can plot all the KPIs that Nokia defines, and you can visualize it. So in our current dashboards, we have selected a set of KPIs to visualize it, and those are available accordingly. So going to the next part on Grafana dashboards for alarms. So the software, the Grafana software, using this Grafana software, the dashboards are created for alarms as well, wherein a customer partner can go and visualize different alarms in the system. So the alarms are shown in the panel with the number of alarms that are currently existing in the system, and one can view the alarms with by going to the particular panel and seeing for different details of each of the alarm. Similarly, we have another dashboard to view the history of alarms that are generated by the system, and at the summary it will give the number of count of alarms that are seen in the system. So that's come to the end of kind of slides, but I'll take you to the actual dashboard itself so we can see the different metrics over here. So currently, as I explained, this is the Grafana software, and the dashboards are available for multiple dashboards are available, and this dashboard plots all the performance related KPIs for 4G network. So as you see here at the top, you have a network group name, which will tell the network slice or the network for which the data is being displayed. So here we have one of the network which is hosted in Dallas in US region, and it's one of the demo lab network. So I have selected that network, wherein you can see the metrics being displayed for that. So similarly, if you have other slice, you can visualize all the data in the single dashboard by selecting the right network and visualizing the data for that particular network. So here we have another network which shows data for that, and we have another demo network which is also available in one of the offices. So then if I come back here, then you can see the list of access points that are connected in this particular slice. Here we can see the three access points with their identification number. So if you select one of the IDs, and then the data is displayed only for that particular eNodeB. So this eNodeB has two cells, two carriers, wherein you can see the cell 1 and cell 2 is there, and both data is plotted separately. So you can select in the legend, you can select the cell for which the data needs to be seen. You can select here, and you can select for the other, or if you can select the both. So each graph is seen individually. So this is one option. As I said, then you have an option to view the data at eNodeB level, which would say that how the overall at the eNodeB level, how the network is performing. So coming to this KPI, it talks about the cell availability ratio. That's why you can see that this eNodeB has two cells, and both the cells are up and running. So its availability is always 100%, except for a short duration wherein it has been resetted and it is back at this time. So yeah, these are some of selections or filters one can use to to visualize the data. Then as I shown here, you have the time selection, wherein one can select the time duration and view the data. So by default, it will come with the default time of 24 hours and some duration. And if you want to view it for last 2 days, you can just select the duration and see the different metrics in this region. So since there is not much activity, we don't see much of the throughput kind of metrics here. But this panel will provide the average and max PDCP data rate in uplink, and this panel will show downlink data rate. And this two panels will show about the current uplink and downlink data rates, and the last panel will show about the current active number of UEs that are connected in this network. So currently we don't see any of the UEs here, so it's showing us 0. Okay, so coming to the list of KPIs here. So in the summary, as we saw, we consider these are some of the critical KPIs. One can visualize quickly on the cell number of cells up and down, and uplink and downlink data rates, and the UE quantity. So and the KPI dashboard will plot many KPIs that are seen as important for any of the operations or customer to view it. So the list of KPIs that you see here is on the cell availability ratio, and you see on the LTE quantity and RRC connection setup attempts, and you have on RAB setup attempts, and even RRC connection re-establishment success ratios. You have radio bearer attempts and RRC connected UEs. Then you have PDCP SDU volume in downlink and uplink rate, and average PDCP layer throughput in uplink downlink. And similarly, you have other KPIs, some on the RAT setup attempts, RRC setup success ratios, and coming down further, some of the PRB usage KPIs. Then you have UE throughput KPI. Then finally you have a couple of KPIs on handover, on interfrequency handover and interfrequency handover KPIs. So these are some of the most critical KPIs that are plotted and available in this single dashboard. For the customer or the partner, this is a kind of a set of important KPIs, but this does not limit for operations or for the partners or customers from viewing more KPIs. So one can easily add more KPIs to the dashboard and view it. From the overall dashboard's perspective, we do provide another 4G PM KPI dashboard, wherein there is a huge set of KPIs available from Nokia defined system report, wherein you can go and see all the different set of KPIs. So on cell availability, you have another two KPIs defined. One is the cell availability ratio and the cell availability excluding the blocked user state. So those are two different KPIs. On RACH attempts, you have more KPIs. Similarly, one can go and see the list of KPIs available. So this dashboard will has more and more KPIs, so which you can consider around 200 plus KPIs are available, and one can visualize it over here. So coming back to the dashboard with KPIs. So from this dashboard, one can go to different dashboards. Here we talked about the 4G KPIs. Similarly, we have dashboards created for 5G KPIs as well. So here you can see the system program report generated for the 5G KPIs. Here we are connected to one of the other lab where we have 5G G-Node based setup, and you can see all the KPIs plotted for the 5G network. So the 5G network, for 5G network, we have three different dashboards created. One talks about the system program report. There are other two dashboards which talks about the accessibility set of KPIs. You can see the signal success HDNB reconfiguration or configuration data on this set of KPIs. And you have another dashboard which provides on the retainability set of KPIs. So here you can see different RRC and connection KPIs. So these are some of the dashboards that are pre-configured and available for the partners or customers to visualize different metrics, performance metrics data in the network. Then coming to the radio alarms. So we have this radio FM active dashboard. In this dashboard, one can see the different alarms that are raised in the system. So you can see we have alarms currently with a count of 2 major alarms and 2 minor alarms visible. So if we scroll down a bit, we can see those list of alarms that are being seen. So this is generated in one of the lab. So you can see this when the alarm is being generated and when the alarm was last updated and what was the device number on which the alarm is being raised, and you can see the network from which the alarm has come. We can see the alarm ID of the particular alarm and the severity of the alarm. Then um, then the specific problem, which would say the categorized ID defined for the particular alarm by Nokia radios, and the alarm text will tell the issue that is seen or the fault that is seen with the fault that is seen with the radio. Here you can see it as base station operation has been degraded, and the additional text would provide the details on what is the issue that is seen. So in this case, it says that top clock tuning failure. So there's some failure with the clocking system. So which has been providing the details on this. So similarly, if we have other set of alarms generated at the minor category, so we can see that see those alarms as well by going to that particular section. So we have one more dashboard for viewing the history of alarms. So if one needs to go and see what has happened in the previous duration, then you can go to this dashboard and see all the alarms that are generated. Here you can select the network on which you want to filter it out. Either it could be the Dallas network, and you can even select the access point for which the alarm needs to see, and if you can even select the select the severity of the alarm and view those alarms only. So these are some of the options available to filter it out. Then coming to another set of dashboard that are available. We have another dashboard which talks about the NDAC system alarms. Here in this case, if I go back and explain in the diagram. So the NDAC system itself is monitoring different endpoints. It could be the edge cloud, or it is also the access points that are connected to the edges. So whenever if there is any connectivity lost from the edge to the access point, the NDAC monitored or NDAC managed systems would generate alarms for those endpoints. So in those cases, in those cases, those alarms that are generated are available here, and those can be visualized in these dashboards. There are two different kind of alarms that are available to monitor. One is the access point failure alarms, or the edge cloud failure alarms. So say if the edge connectivity is lost, there will be an alarm raised by the service which is running on the NDAC cloud, and those alarms would be visualized here. And we have other applications that are deployed on edge cloud, and if there are any alarms that are generated by these applications, even those applications alarms would be visible in this dashboard. So these are here also we have a history dashboard where one can go and see the list of faults that have happened in the past duration. Here you can see there are 3 critical alarms and 1 warning alarm, and the alarms that are cleared. So here you can see that the access point is not reachable alarm is there, and we have edge module not reachable alarm warning. This is at the high level how the system can be monitored using the Grafana dashboards, which is deployed in the external system. So now coming back to the presentation. So so these kind of dashboards are available. As I shown, the dashboard is all viewed from this Grafana dashboard. So one might ask, like, how do we get this whole setup done? So for this purpose, the customer need to have their own Linux box available. The OSS mediator is developed as modules, as a Go programs, and it is a software which can run on any Linux machine. The Linux machine can be either any bare metal machine or any cloud instance, or any flavor of Linux would be fine here. So it can run on any of the Linux machine, and we have a complete setup available wherein we can this can be installed on the Linux machines. So coming to the question, like how one can get access to the data, or how one can do the installation. On our info center, we have a page which will provide the details about all the configurations that are needed to set up this OSS mediator and the Elasticsearch plugin modules. So then on this page, we have listed the hardware that is needed to set up the OSS mediator. So as I mentioned, the whole package, the whole OSS mediator can be installed on any bare metal or on any cloud instance. And coming to the hardware requirements, these are some of the recommended requirement, wherein the system should provide at least a RAM of 18 to 16 GB, and the system should have a minimum of at least 4 core CPUs, and the hard disk storage generally it depends on the number of eNode Bs are connected, but approximately you can consider if you have 100 access points and if you want to store for a year, you would need somewhere around 1 terabytes of space. So this can be extrapolated depending on the number of eNode Bs and the number of carriers that are deployed in the network. So we are providing the software in this section. So in the software package section would provide the software package. In this page we describe what are the different modules that are packaged as part of this downloadable software. It has a module for OSS mediator collector and Elastic plugin, and the JSON files. These are all pre-configured KPA and alarm dashboards, which are available as a JSON files. So these are all packaged as part of this installation, and we have a set of configuration files that one needs to set it up. And we have written this startup.sh script, which will do the complete installation. So with just making few changes to the configuration or making the needed inputs that are needed for configuring the system, and if you just execute this startup.sh script, the complete installation would be done within few minutes. So this is it's been completely automated. So all that one need to have is have a Linux system and a Docker being installed on that system. And if that system has access to internet, then it would just download the needed software, and it will install it. So you can have this Docker installed, then pull this package, which is available as a downloadable package, and put it onto that Linux machine, and just do at a high level unzip the package, and the startup.sh script would be available as part of that. If you execute that script, then the rest of the installation would be done automatically. So at the end of the installation, you will find you'll get an URL stating that you can connect to this to connect to the dashboard, the Grafana dashboard, using the IP address of the Linux machine, followed by the port and the dashboard section. So once you enter this, you will land into the page. Land into this dashboards page. So there, all these dashboards would be pre-installed, and it will be available for to access it. So then you can go to different by clicking on different dashboards. You can go and start visualizing the metrics. Okay, so if you want to, there are the configuration there are guides as well. The OSS mediator collector configuration guide, which will explain how the data is being pulled for the performance management and fault management system. So this is the same architecture diagram. It is all been explained over here, and there are configurations that are needed. The different configurations that is explained here, how one can update these configurations files and get the data. Thanks. This is the end of the presentation.